So as you read through example 2, you're going to see that the author has told us that the population of this city follows an exponential model. And because it follows an exponential model, we know the general formula for both exponential decay and exponential growth. As I said before, the letter itself doesn't really matter, but the author did ask us to write down the exponential function in terms of the function letter n. So you'll see I wrote that down here. In part A, n of t is going to be n sub 0 e to the kt. Now, we won't know whether this is going to be an exponential growth problem or an exponential decay problem until we get a little bit more information. So let's check out part B. As you look at part B, you're going to see that the population is going downhill as the time goes on. That means that this is going to be an exponential decay problem. So our k value then is going to have to be a negative value. So now that we know that, then we can go ahead and move forward with this exponential decay problem. Now, you'll notice on the board what I've done is I've created a table for the information that they provided. So we have year of 2008, population of 900,000, 2010, 800,000, and then they ask us, what's the population in year 2012? So I put a question mark in the population spot. Now, instead of using the year for your t value when you go to your function, it is frequently the case that you want to come in and just find a smaller number to play with. So instead of plugging in 2008 for my t value down here, I think about this population of 900,000 as my initial population, and that initial population is going to be associated with a t value of 0. So once I've decided that this year, 2008, is associated with a t value of 0, then I can go ahead and find t values for all the other years as well. 2010 is 2 years later, so that means my t is going to be 2 there. 2012, 2 more years later, so we're up to 4. So now let's go ahead and see what happens then when I think about these t values instead of the years. My population of 900,000, once again, is my initial population. So I can call that n of 0, but I can also use the notation from my formula, n sub 0. They're the same idea. So I've written it as n sub 0 on the board, but you could also write it as n of 0, because again, they're the same idea. Next off then, 800,000. Well, that is going to be the population associated with a t value of 2, so this is going to be n of 2. Well, okay, let's see what we can do with those two pieces of information then. I know my general formula is n of t is equal to n sub 0. Well, n sub 0 is 900,000, so we're going to have 900,000 e to the kt. But in my second line, I have n of 2. Well, I in fact can play with this n of 2 in two different ways. So first off, down here, I'm going to say that n of 2, in terms of just plugging stuff into a function, I'm plugging in a t value of 2. So that's going to be 900,000 e to the k times t, but my t is 2. So now that I have that, that's one way of thinking about n of 2. But from my table, I also know that n of 2 is equal to 800,000. So I can come in and say that this is equal to 800,000. So now what I'm going to do is focus my attention on the last two parts there. 900,000 e to the 2k is equal to 800,000. And as you look at that equation, the only thing that's left there is the variable k for my decay rate. So we can actually come in and solve for k. So now that we know that we're going to be solving for k, I want to try to get this k alone. Well, one thing that is hanging out with that k is this 900,000. So I'm going to go ahead and divide both sides by 900,000. And in general, when you're looking at this kind of problem, you want to play a similar game to that to get the exponential alone. So I'm dividing by 900,000 to get the exponential expression alone. Oh, okay. That's going to be e to the 2k then is equal to 800,000 divided by 900,000. My right-hand side, though, has all those zeros that I can cancel, so it ends up telling me that e to the 2k is equal to 8 divided by 9. Now that I have the exponential statement alone on the left-hand side, this is now an exponential equation that I can solve using techniques that we've talked about earlier in Chapter 6. So remember, every time that you have a k that is trapped in the exponent like this, you can take your exponential statement and rewrite it as an equivalent logarithmic statement, and then that equivalent logarithmic statement might be able to help you move forward in the problem. So let's go ahead and take this exponential statement and rewrite it as the equivalent logarithmic. Well, the base of my exponential statement is e, so the base of my log is also going to be e. So I'm going to have the natural log of 8 divided by 9 is equal to 2k. Now that I have that, I can divide both sides by 2, and I've solved for k. So k is equal to the natural log of 8 divided by 9, all divided by 2. So now that I know that, then, I can come back to my original statement here and plug in that k value. So I now know then that n of t for this problem is going to be 900,000 e to the k, well, I just found k to be natural log of 8 divided by 9, all divided by 2, times t. So this then is the formula for this specific problem. The population of this city can be modeled using the equation 900,000 e to the natural log of 8 divided by 9, all divided by 2, times t. Now, you'll notice on this problem, I have chosen not to round k. In general, if you round k too early in your problem, you're going to run into some problems later on, and it can end up being the difference between a correct answer and an incorrect answer in the MyLab math system. So what I'm going to suggest is that you just go ahead and leave k as an exact value on these kinds of problems until you actually do the calculation for the problem. So it's not a calculation step yet, so I'm not going to go ahead and do any kind of decimal approximation for k. So let's go ahead and finish off the problem. So coming back to my table then, they're asking me for how many people are in this city when we have year 2012. But again, remember that's associated with t value of 4. So what that means then is that this problem's asking me to go in and plug in 4 into this function. So let's do that. N of 4 then is going to be 900,000 e to the natural log of 8 divided by 9, all divided by 2, times t, and that t is going to be 4 here. So let's go ahead and put times 4. So now that I have this, this is the place where I'm going to be doing some calculations. So this is where I would go to my calculator and actually do some approximations. Once you're typing in things, that's where you're going to do the approximations, the roundings on your answers. Now, sometimes people come in and they try to start at the left, and they do 900,000 times, and then they go to the E button on their calculator, and then they do all of this over here. Well, if you do that, what's going to happen is that you're going to have layer upon layer of parentheses. And if you want to do that, you can do that as long as you're really careful with your parentheses. What I would suggest, however, is instead of doing it that way, to go ahead and just start with your exponent and then move forward from there. So the first thing that I would do on my calculator is type in the natural log of 8 divided by 9. So we would have natural log, parenthesis, 8, and then division slash 9, and then I would close the parentheses. Now, at this point, you could go ahead and divide by the 2, but you don't necessarily have to do everything at all at once. So what I would do is just type the enter button at this point and get a decimal approximation for that. And I would leave all of those digits sitting on my calculator screen. I wouldn't try to round to one decimal place at this point, because again, that's where things start causing problems. So if you round too soon on these problems, you're not going to be getting a correct answer. So just leave all the digits on your calculator screen. And then you can come in and do a division symbol, and what your calculator will do is it will say, oh, I already have something sitting here from the previous line, and it calls it ANS. So the moment that you put that division slash, it says, oh, I'm going to take the answer from the previous line, and I'm going to divide by 2. And then I would press enter. And then I want to take that answer and multiply by 4. So I would press the multiplication button, and again, your calculator would automatically give you the ANS in front of that, and then do the 4, press enter. And what we now have then is the decimal answer for our power. Now, it's the whole thing with all the digits. We haven't rounded it at all. So now we can come in and say, oh, I want to take e to this big decimal. So you can go e to the button, and you have the answer button on your calculator. So up here on steps 2 and 3, your calculator automatically put ANS, but there's actually an ANS button sitting on your calculator. So if you think about where it lives, it's a second button. So you can press second and then another button and you can get that ANS. So you type that in, and once you've typed that this time, you can take e to that ANS and get the e to that power. And again, then I would enter. And the last thing that I would do is multiply by that 900,000. So we have an answer here, so I would do the multiplication, and again, when I type the multiplication dot, it automatically puts ANS in front of that, and then I want to multiply times 900,000. And I would press enter. And now we have the answer for n of 4, and I didn't have to round anywhere along the way. So one more time, if you want to, you could go from left to right, but if you do that, you're going to have to be extra careful with your parentheses. If you follow the process that I'm showing you here on the board, you're not going to have to worry about parentheses as much. So once again, I would start with the natural log, then type the answer piece, divide by 2, multiply by 4, take e to that answer, and this is the one place where you do actually have to type in that ANS button, and then finally multiply by that 900,000. Now, if you've followed along and you've done all of those steps, you should now have a number for this one. And again, we have to decide how we're going to round. On this one, it's talking about the number of people in a city. So again, I think it's reasonable to go ahead and round to the nearest person. So if we round to the nearest person, we have about 711,111. And again, it's all about people. So if that's not the number that you got when you typed this into your calculator, I want you to go ahead and try it one more time and make sure that you can do all of these calculations on your calculator and get this same answer. So we have 711,111 people in the city in the year 2012.